Good morning, everybody. Welcome to Friday's Maths, where we are going to build on what we did yesterday and have a bit more practice on dividing 3-digit numbers by a 1-digit number. We're also going to have a little look at kind of some word problems that also go back to what we did by dividing a 2-digit by a 1-digit. You know the drill. Starter, please. Have a go at these questions. Remember, this means 816 divided by 4. Same for this one, divided by 3. Have a little go. Pause me and then come back for the answers. Right, let's have a look here. Hopefully we've done all right there. This was a bit of a throwback, this one, to your multiplication we did earlier in the week and last week. So fingers crossed you got on all right with that. Okay, so first things first, I wanted to revisit our part-whole method, again, as something that might work for some of you to either visualise or to actually get the answers to your questions. I'm going to put my hand up and say this actually isn't my favourite method of doing it, but perhaps for you guys, you enjoy it. Okay, so Dexter's got 208 divided by 8 as his question, and he's going to have a go at answering it using the part-whole model. So what Dexter has done is he's taken the number 208 and he's split it into numbers that he knows would be in the 8 times tables. Yeah, so he's kind of chunked it off into parts. Okay, now this does involve taking quite a long time to kind of split it up, but for some of you, like I said, your brain's going to straight away go, oh, I know how to split that. Okay, so if we look here, luckily Dexter's done the hard bit for us. So he split 208 into 80, 80 and 48. If we added those together, we'd get 208. And he's going to do each one as a division. The good thing is, when it becomes like this, we can do these divisions using our multiplication knowledge. So I know 80 divided by 8 is going to be 10. Exact same thing here, 10. And 48 divided by 8 would be 6. Therefore, the answer to the question is 10 add 10 add 6, 26. Now, hopefully, we're going to find that we'll get the same answer no matter which way it's split up. The idea is you always get the same answer. It's just different ways of doing it. So if we look down here, he split it this time into 160 and 48. Well, if I know 16 divided by 8 is 2, I know 160 divided by 8 will be 20 because it's 10 times more. And again, I've got that 48 divided by 8, which is going to equal 6. 20 and 6 would be 26 again. And this time we've got it divided 160, 40 and 8. So we've just split it again. So 160 we've done would be 20. 40 divided by 8 would be 5. And 8 divided by 8 would be 1. Therefore, add them all together, we're going to have 26. All right, so the answer is the same. The splitting is different. Why don't you have a go? We've got 132 divided by 4 here. How could you split 132 into equal groups that could be divided by 4? Groups that are in the 4 times table, for example. I might say, okay, I'm not going to do the actual model here, but if I was going to split 132, I might go, okay, well, 40, 40, and no 40s in the 4 times tables. 40, 40, 40, that would be 120. I'd then have another 12 left. So I could split it into those 4 bubbles and then I could divide each one by 4, add them together. Why don't you have a go? See how many different ways you can make these part-whole models with this calculation. Okay? Right, hopefully that was useful for you to have a little explore with. Now we've got a word problem, like I said, for our 2-digit by 1-digit. So what I'm going to do is I am going to write out my rucksack here. Ooh, a bit dodgy. Sorry, my hands aren't doing such a good job today. There we go. Rucksack. So, first thing we always do is we read. So, Henry is decorating 3 cakes. He has 19 strawberries and 41 cherries to share fairly between each cake. How many of each fruit will be left over when he has finished? Okay, we've read it. Now let's underline. So we've got 3 cakes, 19 strawberries and 41 cherries, and we're going to share them between each cake. How many will be left over. Now that word left over makes me think remainders, okay? And the fact that we're sharing this key word here makes me think divide. So the word share helps me choose my calculation, which is to divide. And actually, because I've got two different sets of numbers, I'm going to have to do two calculations to work this out, okay? Because it says each fruit. So if I start with my strawberries, what it's saying is if I'm sharing between 3 cakes and I've got 19 strawberries, what would that be? So 19 divided by 3, okay? How many groups of 3 can I make out of 1? Sorry, I keep having all these notifications. How many groups of 3 can I make out of 1? I can't make any actually. So I'm going to carry the 1 over. If I've got 19 and I'm dividing it by 3, then I'm going to have 6 groups of 3. And I'm going to have, how many would that be left over? Remainder 1. Yeah, because 6 groups of 3 is 18. I've got 19, so then I'd have 1 left over I couldn't make into a group. And then I want to do the same for my cherries. So I've got, I'm dividing by 3 and I've got 41 cherries. Exactly the same as before. How many groups of 3 can I make out of 4 tens? I can make 1 whole group of 3 and then I'm going to have 1 left over, which I carry. So now I've got 11 ones. How many groups of 3 can I make out of 11? 3, 6, 9, 12. Okay, I haven't got enough for 12. So 3, 6, 9. 3 groups. And then I'm going to have, if I've used up 9, but I've got 11, I'm going to have 2 left over. So I think I've solved the question. However, let's just check. The answer should be, so how many of each fruit will be left over when he's finished? So just writing 6 remainder 1, 13 remainder 2 won't give me my answer. So therefore, I need to say there will be, my answer needs to be, so answer equals 1 strawberry left over and 2 cherries left over. Okay, again, perhaps you can think about how you would check that using the inverse. All right. Okay, let's have a look then. So we've got Francis, Usman and Gina have had a go at doing 87 shared equally between 5. Which one of them is correct and what mistakes have they made? Perhaps before we go any further, before we even work it out, could you think about who might be right and who might be wrong? Okay, so straight away, I can see Francis has got a remainder of 7. Well, if I'm dividing by 5, I cannot have 7 left over. I'd be able to make another group of 5 out of those. So straight away, I know Francis is wrong. I also know that if I'm sharing equally between 5, I can use my 5 times table. Anything in the 5 times table ends in either a 5 or a 0. 87 does not end in a 5 or a 0. So I know my answer is not going to be exact. That will not be in my 5 times table. So Usman, I think, is also incorrect. Now let's test it. Let's wait and see. But I believe I'm going to predict or estimate that Gina is correct. So let's have a look. We've got 87. Put the answer I'm dividing in the bus stop. My 5 on the outside. How many groups of 5 can I make out of 8? I can make 1 group and I'll have 3 left over. Now I've got 37 because I've carried that 3. How many groups of 5 can I make out of 37? Well, 7 lots of 5 are 35, so that'd be 7 groups. But then, like Gina said, I'm going to have 2 left over. So sometimes before we even do a calculation, we can use our knowledge of multiplication and division to help us work out which ones might be the wrong answers. Okay? Right, thank you for sharing that one with me. Have I got 2 things left with you? Yeah, 2 things left. Right. This one is a little bit more tricky. So, the workers at Twinkle Bakery have baked 679 cupcakes, all coming to me, by the way, and they're going to package them ready to sell. Complete the table. Now, if we look here, what's it asking us to do? What this is saying is, in different types of boxes, you can fit different amounts of cupcakes. You can fit, so these ones 3, these ones 4, 5, and so on. Okay, so if we can fit, so this one, we can fit in 3 cupcakes per box. What it's asking us is, what would our total number of full boxes be? Well, to work that out, I'm going to need to divide that 679 by 3 to work out how many could go in each. So 679, if I divide it, I'm so sorry about my handwriting today, guys. It is appalling. Must try harder. If I divided that by 3, let's have a look. How many groups of 3 can I, or boxes of 3, shall I call it boxes? How many boxes of 3 can I make out of 6? I can make 2. No left over. How many boxes of 3 can I make out of 7? Again 2. But I'll have 1 left over to carry. And then how many boxes of 3 can I make out of 19? Well, 3 lots of 6 is 18. So that'd be 6. And then I'd have 1 left over. So my number of full boxes would be 226. And my number of cupcakes left over would be 1. Okay. That's for if I was putting them in boxes of 3. What about if I was putting them in these boxes? Well, that would be 4 per box. So how would I work out the answer to this? What do you think? Hopefully you went, just do the same, divide, but this time by 4. So 679 by 4 you'd do this time. All right. So what I want you guys to do, we've done the first row together. I've given you a hint on the second row. Pause me here. See if you can fill in the table by doing each one, by working out how many in each box, dividing. And then once you've got a complete table, the final thing I want you to think about is which size box would be the best to use? What would you suggest? Explain your answer. Now, what I'd say is pause me here, fill in the box, decide on what you think your answer could be, and then I'll explain which my answer would be. Okay, so hopefully you've filled this in, and perhaps, I don't actually know because I haven't filled it in yet, I'll do it afterwards. Perhaps you've found one where you've got full boxes with no cupcakes left over. I would say for B, whichever box provides no leftover cakes, because we don't want leftover cakes. You want to sell them all, don't you? Whichever box has no cakes left over are the boxes that I would package my cakes in. Okay? Right. Final thing then, just a bit more fluency practice. As always, there's some problem solving and reasoning for you to tackle and explore. A few more of those word problems, they'll be on the website. But in the meantime, what I'd suggest is pause me here, have a quick go, a refresher on here if you're feeling like you need a bit more practice. Then I will reveal the answers in just a bit, and then you can have a go at the word problems. If you're feeling super confident, then I'd suggest go straight on to that problem solving and reasoning, word problem, etc. Okay, well done, guys. It's been a pretty tough week, I'd say, in terms of maths. We've had loads to cover, and I know for some of you, it's felt like quite a lot, and there's been sticking points for you. That's totally normal. We've whizzed around lots of bits, and I'm feeling really proud of the effort and the resilience that you have shown. Okay, you will be joined. I'll be doing Monday's lesson, and then for the rest of the week, Miss Rutherford will be with you, and I know she's really looking forward to it. Okay. Take it easy, guys. I will just pause me here and then I'll reveal the answers, okay? Right. Hopefully, these are the answers you got, all with remainders. That was the thing that we were exploring today, okay? So if you didn't get these answers, have another go. If you're still not sure, drop me an email and I'll be happy to help you out, okay? Take it easy, everybody. Bye.